Let's draw some Lewis structures of some molecular compounds. Remember that nonmetals, when they bond with one another to form molecular compounds, they form covalent bonds, and they do so to try and be more like the noble gases. So we say they're trying to obey the octet rule, which says they're going to try and get 8 electrons around themselves. Now there are exceptions. For example, hydrogen is happy with just 2 electrons. We say it's looking for a duet. So let's take a look. Let's do water. Okay, so first step in drawing a Lewis structure is to sum the valence electrons. Remember, the valence electrons is equal to the A group number. So hydrogen is in group 1A, so it has 2 times 1, plus oxygen is in group 6A, which is 6. So 2 times 1 plus 6 is 8 valence electrons. So when we draw the Lewis structure of water, we must use 8 valence electrons, no more, no less. Second step is to draw a skeletal structure, which is just a bare bone structure. There are some rules for determining which atom must go in the center, and a really easy tip is if carbon is in the molecule, put it in the middle. The least electronegative element should go in the middle, and also make the molecule symmetrical. So for example, we've got 1 oxygen and 2 hydrogens, so I put the oxygen in the middle. The most important rule is that hydrogen can never go in the middle. Hydrogen can only make 1 bond. It's only got 1 electron. It can only have a duet around it. So it can only make 1 bond. If we were to put hydrogen in the middle, it would have to make more than 1 bond. So hydrogen can never go in the middle. It's always on the end. We say it is terminal. Okay, so we've used 4 electrons in this particular drawing because remember this line represents a covalent bond, which is 2 electrons. So we've used 2, 4 electrons. We have to use 8, which means we have 4 left. Now our next step says that we should assign those remaining electrons to the terminal atoms first until they have an octet. But our terminal atoms are hydrogen, and hydrogen can't fit an octet. It just needs a duet, and they each already have a duet if they formed a bond. So that means our 4 remaining electrons must go on the oxygen, like this. And that gives the oxygen a full octet. Each hydrogen feels like it has a duet. So our check should be, does everything in the molecule feel happy? In other words, does everything have an octet apart from hydrogen, which wants a duet? In this case, yes. Oxygen has 2, 4, 6, 8. This hydrogen has 2, this hydrogen has 2, so they each have duets. And then your final check should be, have you used all of the electrons available for the structure? We've used 8, so we're good. Okay, let's do another one. Okay, so sum the valence electrons. Carbon has 4, plus 2 hydrogens is 2 times 1, plus 6. So we've got 4 plus 2 plus 6 is 12. Go ahead and put carbon in the middle. Hydrogens must be terminal, and then the oxygen is also bonded to the carbon. Okay, so far we've used 2, 4, 6 electrons, and we have to assign 12, so we've got 6 left. So start assigning them to the terminal atom first until the terminal atom has an octet. Remember, hydrogen can't have an octet, so I don't want to see any dots on hydrogen. Just go ahead and put those dots on oxygen in pairs. So we've used 2, 4, 6, 8, 10, 12. We've used all 12 of our valence electrons that are available. So then you ask yourself, is everything happy? Do the hydrogens have duets? Yes, they do. Does the oxygen have an octet? Yes, it does. 2, 4, 6, 8. Does the carbon have an octet? 2, 4, 6. No, it doesn't. So carbon is not happy. So what we have to do then is make a multiple bond. And by multiple bond, I mean a double bond or a triple bond. So to make a double bond or a triple bond, we have to take pairs of electrons, lone pairs of electrons from the terminal atom and move them into the bonding region. So we could take this group and we could move it into the bonding region here. Since I'm using a pen, I'm going to have to redraw it. So let's try that. So now we've still used 2, 4, 6, 8, 10, 12 electrons. hydrogen has a duet, hydrogen has a duet, carbon has an octet, oxygen has an octet. So this is the correct Lewis structure for that molecule.